now if you've heard it before. Well, one, you get a discussion of PEP from someone who's really not involved in active promotion. Not that people shouldn't be involved in active promotion, but I have a different viewpoint. You get a view from deep inside the brain mines, which is where I hang out. Some nitty-gritty details if I wake up some more, which the beer may not help, but I'll try. And if I speak too fast, somebody raise their hand and say, oh. I also only started working there 7 months ago. So that means that I basically started with the code and had to figure out how the engine worked from the ground up. So I may not always have the high-level view, but I do know how things work on the inside. And that may help bridge this gap we have between PEP, well, what PEP is, which I'll discuss in the next slide, and what it really does underneath things. You'll also have the opportunity to ask questions of someone who isn't producing the shiny parts, but with the addendum, or the addition that the shiny parts are extremely important. I'm just not qualified to produce them, and I have respect to anybody here who does design a UI or makes usable stuff and makes it aesthetically pleasing. We need you, so that I'm not dissing anybody who does that kind of stuff, okay? What it's not a white paper. That was a condition of hiring me, that I would not write any white papers, and I think that's still on the list, right? Or have I just lost that one? Yeah, no white papers for me. They're also not bad, I just don't do them. It's not a comprehensive overview of PEP. We have a lot of documentation on that. We've done several talks about what PEP overall looks like and what it does. I'll talk a little bit about that, but that's not my main focus here. It's also not all the details you could ever want about the dirty parts of the engine, but luckily for you, the repositories are open and you can look at that yourself. And you can contact me anytime you want, and I'll say, I don't know either. I'll learn. I'll figure it out. It's also not the product of sufficient coffee. They didn't give me enough at breakfast this morning, so sorry. And it's not entirely finished, but I'm doing my best. But the question then is, what is PEP? How many of you here have already watched a talk about PEP or read something about PEP? Or, okay, so about half of you. So I should give a little bit of an overview, but what you'll get is my unofficial answer. And please do not hurt me, Leo. This is how I see it, and if I get it wrong, throw something at me. If this works. Hello? Yeah, okay, it's just not there. Yeah. Oh, yeah, okay. If you knock me out, I don't have to give the rest of the presentation, so we're good on that one. No, I'm not unhappy to be here. I'm just scared. PEP is an opportunistic encryption-based messaging system. That means that we want to be able to make it possible for you to send messages back and forth and encrypt them when it's possible and wherever it's possible. Our overarching design goals, which means that we rate this higher than other security goals in many cases, although we try to be as secure as possible in all cases, is preserving user privacy. And that includes making sure that metadata is unavailable when it can be made unavailable and not make the protocol unusable. And implementing a secure core of the system, which is based upon best security practices. And so our goal is to have a piece of so I work on the engine, and that engine should be implemented in a way that is as secure as possible, because everything that's on top of PEP uses the engine. It aims to, and this is a very broad statement, but I don't want to start listing things off. It aims to support every messaging protocol and system we can get our hands on and into. So if we can get the source for something and it's being used, and we can work with the people who are producing that, we really want to find a way to integrate that into PEP and to help the people developing that system to use PEP. We want to use a wide variety of transport mechanisms. There's a lot of talk about how we are working with GNU-net. It's a project I used to work on. We're not quite there with GNU-net yet, but we are at least working together to get our stuff working on top of GNU-net. And this one, I'm not going to make you guys read this. It's up there so I remember what I have to say. And I actually would like to give an example before I start. So, have any of you taken a linguistics class at any time? What? Linguistics. The abstract study of natural languages. Yeah. Okay. Well, there's this idea that people give a lot of times about complexity in language. So you have things like syntax, morphology, which is the word pieces that you have in a language. You have semantics, you have pragmatics, which are the things outside of the grammar that also add to the meaning of what you're talking about. And all of those things are kind of in all languages. But in some languages, they're more complex, and some they're less. So if you look at language like a balloon, and you grab the balloon where it's least complex, like in the syntax area, it expands the complexity or the size of the other parts of the language. So basically, you always have a certain amount of complexity in a system. And when you reduce it one place, you increase it in others. So one of our big problems as crypto nerds, at least for me, a big problem in our community, is that we have these incredibly complex systems which do good stuff for keeping data confidential, for keeping it private, for keeping it integral. But it's terribly hard to use, right? When everybody knows this is a problem, everybody complains about it. At the same time, there are people who make great user interfaces and are really good at making things usable for people. But they don't know how to write secure code in a lot of cases. And so what we want to do is keep the cryptographic and protocol and algorithmic complexity on the engine side for people who know how to write those kind of secure systems, and keep the application level complexity on the other side of this balloon for everyone. In the middle, we have something called an adapter, which is a really easy interface for those two parts of the system to interact. So the people who are experts in one system use their expertise in those systems because this is a complex problem. The people who are experts on the other end of things use their expertise on those complex systems because it's a complex problem, and they have an easy way to interact with each other. And this is how we're able to hopefully produce something that is easy to develop for people, and they can use their strengths for that. Because if you made me make a UI, it'd look like an old GeoCities page. It'd be great. So. And by the way, some people have argued this PEP is free software. All of our source is available under GPL 3.0. And so if there are questions about the profit model, that has nothing to do with the fact of whether or not our software is free. We have a company so that people like me and the other people that work there can get paid to actually work on the development so that this actually gets implemented. And this is always a problem. So you know, we can talk about that later if you want to, but this is the FSFP track, and it's free software. So how PEP works. This is a beautiful picture. I did not make it. We have Alice, we have Bob, or I don't know which one's which. Maybe that's Alice and that's Bob. And they want to send messages to each other. They both installed PEP. We don't. So that's my mom and that's my dad. Who my dad's really savvy with computers, but he doesn't encrypt anything because it's just too much bother. We don't want them to have to worry about things like key generation. We don't want them to worry about key exchange and verifying each other's keys because they simply won't do it. They'll sit around watching TV and say, nah. We want that to be automated for them, and so that's what PEP does. When you first start PEP, the first time, it generates a key for you. You don't sit around trying to generate that key. You don't have to worry about it. The person on the other side obviously does that. And when you first send a communication to somebody, like I said, we do opportunistic encryption. So we send an email, and on the first email exchange, we send our private key. Or not private key, that'd be better. We send our public key. Private keys everywhere for everyone. We send our public key. So Bob sends his public key to Alice, and Alice is also running PEP. So PEP says, aha, Bob has a public key, and Bob is running PEP because there's information in the email headers that says so. And so she mails back her public key, and the reason the emails are yellow is that they're now both using PEP and using PEP keys, but they haven't verified those keys. We want to make key verification also easy. How many people like reading out hex digits over the phone to someone who's like, okay, yeah, okay, I kind of get it. Look, I'm not going to kink shame here, but anyway. Okay, for those of you who don't and read XKCD, what we really do is we have deterministic trust words which are generated by the hex digits of the keys in the language that the people doing the exchange speak, and they then verify that over the phone or wherever else to verify their keys to each other, that they both have the same sets of keys using these trust words. They both verify that it's done, there's a little handshake, and then from then on, PEP tells them just by virtue of showing that their emails are being sent with a green color, that there was no man in the middle when that was detected, that they are communicating securely and they don't have to understand anything about crypto or key exchange or anything else. So that's the idea. Give people an easy interface to be able to do this with, Don't make people who don't want to know the details and who won't use it if they have to know the details use it, and take over the known world. Okay, that's shiny, but what's really going on? That's why you're here, I hope. Well, the application, in this case, right now, we only are doing email, but we are moving into other protocols. Email is the easiest and first thing to set up. So I want to send an email to somebody. And my app, so let's say Thunderbird, generates Thunderbird and Enigmail, because Enigmail is actually now integrating with PEP, or PEP is being integrated into Enigmail, one way or the other, I don't know. It generates a message text, which has some of the aspects of a message. We have a generic representation of a message that we use for everything, because we want to be able to, at some point, work between protocols. So I can use, say, XMPP to send something to this nice gentleman here in the front row who I know, and he only accepts email messages, but he's able to get that message anyway. And when he gets that message, he can reply using the same format, and I get a message back via XMPP. So we have a standardized format for message text. It might have a subject, it might have attachments, a body, or a header. The app generates those things. It gives information, which is used to retrieve information within the engine about the sender's identity. We have an identity representation, which contains stuff like the fingerprint of the key, the level of trust we have for that identity and key, and some other stuff, which I'll talk about in a minute. And also the same kind of information about receivers, and so on. This can look like a lot of different things, and it really depends upon the application. So, for example, we get, from Enigmail, we get a MIME-encoded mail string. It's the entire mail string. It's unparsed. We get that raw. It has the, well, no. So we get that raw. We do the encryption. We send it back. It contains only web text. We can get a JSON object, a C-struct, or anything else you have an adapter to interpret. But what's an adapter, you say? You said that, right? Everybody? Thank you. What? What's an adapter? Stop making up words, you say. The secure cloud. Big data. The Internet of Things. Bingo. Thought leaders. Please pass my beer. No. An adapter is actually, it really is something, and it's good, and it's vital to the way we do things. What it is it's a language and, moreover, an environment-specific interface between the engine's API, which is a bunch of messaging stuff I'll show you in a bit, and an application development environment. So it makes it, yes, of course, we can all use C bindings to everything. Pretty much every language supports that now and whatever, but we want to make it also easy for those developers to do things. And so it's specific to the application development environment. We have Python bindings, we have JNI adapter, we have a what's the Windows one? The blah, blah, blah. I don't know what the name of it is anymore. You guys know. COM server adapter. I'm just losing my vocabulary, and it's not the beer. It's German. It just ruins my language. The COM server adapter, and a number of other, and iOS adapters for iOS devices. We have adapters for all of these things, so that, and these work within the development environments for people who develop on those systems. So it's natural to use those things, and it's easy, and they only have to think about the functionality they want to use. So I want to encrypt a message, okay, I know what that needs to look like for the adapter. I send the message format, and I say, okay, encrypt that message, and you do, and you get back whatever you're expecting as the developer on the application end. And then you do what you need to do with that message. You don't have to worry about how that is happening. Okay? I wanted the adapter, torn. I'm honest. So what the app does is it makes the appropriate calls to the adapter for whatever function it wants. This could be, well, did I put this on here? I can't even tell. No, okay, throw that. This could be encryption, decryption, MIME encoding. Not everything does MIME encoding, so we do some of it for them, although that's fun. Getting the trust words for people, verifying an identity, all of this kind of stuff. The app makes those calls to the adapter, and then the adapter converts that into a normalized, standardized form that the engine understands. The engine doesn't think about whether this is Xcode, or whether this is, somebody writing Python or whatever else, or what messaging transport they're using at the moment either. So it only knows this form it gets for message and what it's supposed to do. The adapter converts that into normalized standardized form to the engine, and then makes the C library call. And at this point, the app, the adapter, objects, application languages, and whatever, as far as we're concerned in the system, it disappear for a little while. Engine magic here. I'll get back to it, I promise. This process message may end up back at the apple for the app to handle, or once we got more transports implemented, it may send back, go through the engine via transport callback. It really depends upon what you're doing. Okay, stop your hand waiting. Engine magic. Well, remember what I said about complexity, right? So I said engine magic because we push the complexity to either side of the adapter. But really when it comes down to it, as far as the engine's concerned and any adapter implementations, the adapter implementations are wrappers around a fairly small set of functions. Encrypting a message, which is fairly straightforward. Encrypting a message for yourself, that's for example, if you want to save a draft and you don't have a recipient in the field, we have to be able to do that. Sounds like it's not magic, but you still have to do the work. My encrypt message means I don't actually have, I'm going to send you a MIME string, I'm not going to send you a specialized object to the engine, you have to do the whole thing for yourself. Then there's the decrypt message, and I'll explain how encryption and decryption work in just a minute, because it's kind of important. What we do, it's not what we do. Doing that with MIME, getting the trust words, there's some other things, being able to get information about the rating of identities, the trust rating of identities, the binary path for whatever encryption software you're using, etc. We don't do the crypto. And the reason for that is there are some really good free software crypto libraries out there. They're heavily developed. We want to use and support those. And us rolling our own wouldn't be a very smart move, I think. I mean, if we need to, that might be something else. But right now, we are using GNU-PG. And we use NetPGP for iOS because the Apple Store does not allow GPL licenses in the Apple Store. But that's a FreeBSD port of OpenPGP, which is a little harder to use. But that's what we do right now. And basically, when you compile the software, there's two things. When you compile the software, when you compile the engine, you let it know which libraries it needs to look at. But it's also possible that there are callbacks for a particular messaging protocol to a particular library. So the engine does the work of ensuring that the right libraries get called in the right way. So we're not doing the encryption ourselves, but we're making sure that those calls to the encrypt and decrypt calls are done in the appropriate way according to the specifications of those libraries. So we want to keep the secure code in the engine in that sense. Okay, we haven't seen the command line yet. Man, this is not technical talk. I'm sorry, guys. Encryption with the help of our friend GDB, if I can do it correctly. But of course, you know, wait, no, we don't want any words from our sponsor. Go back. What happened here? Yeah, okay. Let me find the correct window. No. Okay, well, the first thing is this. This is not a very exciting email. It's a mail I sent to myself at 2 different addresses. It is, however, as you'll see in a minute, it's sent to a different address of my own, so it's not just directly to myself. It's encrypted. It is in MIME format, sort of what you expect to see when you decide to dump something from Mail, which is exactly what I did. Has all the nice MIME boundaries. I love MIME. It's my favorite. I lie. Okay, so what we want to do simply, if I got this correct. Oh, come on. Yes! Okay, I have, no, don't do that. Okay, so I have a stupid little script that I use most of the time when I'm debugging if I just want to set breakpoints and see what's going on when I'm doing decryption. Sometimes has encryption calls in it as well. Just so you have a little idea of how this is used, you don't have to recall any details of this, and I know I have a couple of people in here who are non-technical who are going to go, but don't worry, this is a very simple example of how, from the engine point of view, we actually use this stuff. So, we initialize the PEP engine, a lot of stuff goes on there, and all I'm doing in here is I'm reading in the mail file that's going to get parsed and decrypted, which is the one I just showed you. So I set breakpoints at the message decoding because it's in my format, and, oh, come on. You're not going to go down for me? What? 5 minutes in your room and a tip in the square jar. Okay. This is not fun.
We have seen it.
Yeah. You have seen this before?
No, I mean that it doesn't scroll.
Yes, I know you have seen that it doesn't scroll, and I have seen that it doesn't scroll. Now it should. Okay. I decrypt it, and I'm just going to try to show you a little bit about what's happening. So basically what this is a little bit of a simulation of is, at the engine level, when I get a call from the adapter saying, okay, I have a my message here, and I want you to decrypt it. This is what it would have to do. So this is what the engine does. It would say, okay, well, first I'll decode that message, and then I will decrypt it. And I just want to show you what's happening on the inside. If it's boring and you go, then go. Okay, so, yes, of course I want to start from the beginning. Okay, so, I read in this message that I showed you guys before, and the only thing you really need to see is that the text that goes in is just a big long string, which is MIME encoded. You might recognize that by the fact that it has that CRLF. That if you're doing anything with MIME and you don't get the CRLF in correctly, nothing ever gets parsed correctly and everything breaks and you don't know why, and then you cry for a week. Trust me. So this is really just a big string it's gotten and a size. We then, and I'm not going to show you the whole thing, but or show you any of it. Basically, we make a call to an external library called libbadpan. Libbadpan is a very faithful and very, very strict representation of the 10, 15 RFCs for MIME messages. The problem is that most people who use MIME or develop MIME don't actually follow this faithfully, so it breaks on us fairly regularly, so we have to do a lot of work on it. It's kind of miserable. But anyway, we use that to get back a MIME object. And what we get out of this, not a MIME object, a message object. And I will show you a message object in a second. I'll just here that I had it ready. I think I had it ready. Okay. So just when I said that we had this sort of abstraction for messages, it's largely based on email because email is one of the more complicated kinds of messages we can make. It has long lists of two. So, I mean, that would also work for groups, timestamps, people in reply, references, and so on and so forth. But these will be mapped to whatever messaging protocol we're actually using. So if it's XMPP or something else, so some things might map to other things that you're expecting. A short message here, for example, is the subject in an email. It might be something else. In an SMS, it might be, there are SMSs which have subjects as well. The long message is the core of the email, and long message formatted when we're doing email is the HTML section of an email. But it could be something else for other protocols. And so we've sent this to decode message, and what we get out of this is, well, the subject was pardon me. We don't have any long message because it was an encrypted part, and it's in the attachments. And we get this encryption format at the end that says PEP encrypted none. That means that we know that we didn't. Never mind. When we decode something, we don't care that it's encrypted or decrypted. We actually have to decrypt it later. Sorry. Like I said, I didn't prepare quite as much as I wanted here. So we're sending this now to decrypt message. Okay. So what happens here is that I send this to this generic decrypt message function, but obviously I may be running iOS, which is not going to be running GNU-PG. I may be running something else that has an encryption function that we have to determine on the fly. There is a part of the library called Cryptotech, just a big array of callbacks for various encryption functions. So in this case, it's decrypt and verify, and where this goes in our case right now is a function called PGP, decrypt and verify, which will eventually call some code that Neil might have seen before. Goes into GPGME, and we ask GPGME to do our decryption. In the end, we find out that it was positively decrypted and verified. We return that status to the top, and then that will eventually determine the rating for the application level as it goes back up the stack. I know that probably wasn't as useful as you wanted, but it was a try. Okay, so in the end, what we end up getting, I printed out the short message, which is the subject, which wasn't encrypted. The long message, which was, if you know about Hamilton, kind of a stupid joke, and it's decrypted appropriately. The one thing that I didn't do here, because this was not set by PEP, because I'm just working with the engine, is that we actually do subject hiding. So the subject is actually encrypted within the email, and the subject is always PEP or some other specified string, and we replace it from the decrypted message once we return the object, so that at least that portion of the metadata doesn't transfer over the wire. Okay, enough of that. I had a presentation here somewhere, right? Yay. Come back. I'm not really sure how to use it. So the other thing that I wanted to show you guys, but I'm not really sure it's as useful as you might think. Our idea of trust is not trusting a key. We trust an identity and the key related to that identity. And we store that trust in a database that is then, that determines part of the status that we return to the users above. So we look at, when we get a key, and we have the user ID, we look it up in the database and say, okay, well, do we already trust this? Have we verified this key? If we haven't, then we might say, okay, well, we've decrypted this message, and it has a key associated with it, and it was properly encrypted, and it was signed by somebody, but it's not verified. So we return no color, because we only have this 3-color system, and the person knows that they don't know whether or not they can trust this message. So I'm not going to show the schema. That's boring, and I'm boring myself. Yeah.
Can you explain what you mean by you trust the identity and not the key?
Yeah, let me see if I can remember this. This was a conversation with Volker 2 days ago. So with the web of trust, so if I have one key, all of my email addresses may be bound to that, and then you also know all the people that trust me, and you sort of leave a lot of information about that, and I'm going to end up eating my own foot here. And I lost my train of thought. Our idea is more that if I have an identity that I've associated several keys with because I know that represents the same person, but those aren't bound in any identifiable way to the outside, I'm trusting that identity, and so I trust all of those keys to the same amount, rather than putting the trust on the key itself, if that makes sense. So instead of trusting that fingerprint, I may have like 6 fingerprints from some guy, but they're not associated with, they're not associated on some key server.
And how do I assign such an address to an identity?
Well, so Matthias, you know it's me, and you know it's my secret identity, and you know it's my superhero identity. This is something you personally do. So this is
not automated.
This is not automated. No. We want users to be able to, first of all, group identities as they see them. We do not want to be providing that information to everybody. So, you know, I have identities under my maiden name and under my married name, and maybe I don't want those associated because I want to have 2 different exciting lives. Because I do, you know. As long as they don't have the same key, they're not associable. But you know me, and so it's easier for you to say, well, look, if I get a mail from Krista, I trust a mail from Krista.
And so your identity is represented by your name or something?
It's represented by your email address, so a user ID and key within the system, yeah. But yeah, okay, Neil.
How is that different from the web of trust, right? When
Nobody can see it. It's not published anywhere.
I mean, that's separate from the web of trust.
Well, okay, that's the key servers. Okay, but yes, I agree.
That's the social data that gets uploaded to the key servers. So you don't have to upload that data.
I agree. Yes.
So when I verify a fingerprint, like you give me a business card,
Yeah.
I go home, and I verify the fingerprint,
Yeah.
then I can do a local signature.
Yeah, you could do this all locally. And basically, we're just making it by default that there's not this external thing. I don't know. I'm going to say things that are untrue here, and I would rather say I don't know what I'm talking about than to actually lie to you. Volker will be around at 6 o'clock, and I'm sorry, Leon, that I don't know everything, but I try.
No, but if there's more questions about that, Volker can have a session on the topic.
Exactly. So that is not a small topic, and it is not a dumb topic, and I just don't want to say things that are untrue.
Yeah, that's fine.
So, yeah.
Can I only just ask, how do you handle then the fact that not all the cryptography is trustworthy on the same level, right? If you're trusting identity, do you indicate that some...
We do have, there is a Bible in the database of the transports kind of cryptography with trust, and it can reduce the level of trust. So we don't actually, at this point, I think, have any kind of crypto that we're using where that's a problem, but there is actually a binding there which says, okay, so if the COM type, which is an indication of the ability of the value of the encrypted communication, is lower than a certain rating, then the trust on that identity when you send something can't be above a certain color. So we do actually take that into consideration. I just don't know that we're having to use it at the moment. But yeah, at least the structure's there to do it. I've seen it in the code. I haven't seen it affect anything yet, but I also don't see a lot at the top level. I really just work underneath everything. So. Yes, please.
How do you manage revoking keys?
Okay, well, so at the moment, because we're only using GPG, we actually do GPG key revocation, and then within the database, that key is also removed. When we move to other things, that's a trickier question, and I don't know what we want to do. We do have a database of revoked keys, so we can flag that key as being revoked, and so it never gets used. So it depends a little bit upon what the crypto mechanism for revoking keys is on that particular platform or protocol. Yeah.
Maybe kind of a naive question, but what does actually predicate privacy add on top of all the new privacy architecture? I mean, I didn't get it yet.
Okay. It's really, what it adds on top of that really, I mean, unfortunately, if I'm talking about sort of the low-level details, then I'm talking about GPG and you go, yeah, look, I can use that on my own. There are a lot of people who can't or won't. And what we want to be able to do is make a system which is secure, that can be developed, that they will actually still be able to use it without having to generate their own keys, without having to understand the crypto mechanisms, without having to go through the process of verification in a difficult way. So the simplification of that is really what this is. It's sort of a middle layer that does that.
I mean, I develop software. If I want to write a messaging app, for example, for iOS, maybe, which should be secure and should take part into studying using privacy. What should I do? Where should I start?
Okay, so if it's for iOS, once that adapter is written, you have the adapter, the interface, the API basically for interacting with the engine will be there. You'll know what functionality you have, and you use those calls to write your application. So I mean, if you want to encrypt messages, you determine what you want to encrypt, you send it into the engine, you get back an encrypted message in the format that's returned by the adapter, and then you adapt that back to your application. So if you want to know about documentation and where you start, we are working on documentation, but we have a ways to go. And that's just honest. We're getting there. I don't know if I answered your question adequately, but drop out.
I'm still in search for what does it improve in kind of, it provides a kind of unified interface.
Well, that is one thing it does, is it provides a unified interface. The other thing it provides, again, look, there are apps like Signal, which also take this away from you, right? You don't have to worry about that. If you're using Signal, you don't think about your key. I mean, sometimes you get messages that say somebody's security.
I'm looking at it from a developer perspective.
Okay, so from a developer perspective, what is it?
I want to really make this fly. I want to really provide secure communication for people, but I'm the developer and I have to deal with stuff like this. How can you integrate? And now
it simplifies the interface you have to use for doing encryption, decryption, and those kinds of things. I mean, hopefully. That is our goal. So the adapter provides a simplified set of functionality, which, I mean, we have code audits. It doesn't mean that everything is secure, but we are trying to write the underlying security and crypto code as best we can and as securely as we can. If that functionality is already done, then you don't have to go through the trouble of saying, okay, well, now I need to find something that's GPL licensed. So if you're running for iOS, I have to find something that's GPL licensed, which is the crypto I want, so I can stick it into the store. I have to learn the paradigms for doing that correctly. There are some things that are missing, for example, in FTGB, so I have to develop those things myself. It takes that extra work away from you as the developer.
Okay.
So that from an application developer point of view, the idea is if you can get to the point where you trust the engine and you trust the adapter, and that's a big if, you have to get to the point where you do that, and we want to make those things trustworthy, then when you write your application, your concern is, okay, I need this message to be encrypted, and I know what I need to do with it once it is. I need to, have a particular set of particular kind of trust, and I know how to get that out of the system. So it's really trying to shift that away from application developers who are really good at developing applications, and maybe they're good at crypto too, but that's time. And reinventing the wheel again and again and again is difficult. So that's the best I can give you, I think, for that.
As far as I understand, you have something ready, right?
We have some things that are ready.
So you have something where you can start developing something.
Sure.
Which platform there is something
Okay,
available, including some basic documentation, so I could start?
I would say Windows is probably the best at this point with the documentation.
Windows and Android.
Windows and Android both. iOS is in development, it's coming, but it's coming relatively soon.
Yeah.
So we're pretty far on that as well. The basic documentation is moving along very quickly, and I would say, I mean, from what Volker showed last night, I think we're...
I think there's lots of user documentation. The technical documentation is still a few steps behind because it's
But we're
focusing
working on it. So we're at the moment working actively on a technical white paper. So far the general white paper is online, but the technical it's work in progress, which should be coming in the next weeks or so, maybe month. No, well, but it's on the way.
And actually, we are planning on having pep.software for developers to just plug and play.
Okay, cool.
Yeah, it's all in the works.
Yeah.
Maybe,
Like I said.
maybe I add something more to ask you, because what is the difference that PEP does? So one thing is,
And maybe take Mike.
Oh, yeah, sorry.
Get a mic.
Merry Christmas.
No, just to say a little bit on the functionality. So the idea of PEP is that it installs automatically, that you don't have to have any knowledge. Basically, if you take something that's not so popular in here, I assume the Outlook plugin, you just say install, accept license, finish, and it's done, you're up and running. The keys are created, it checks if there were keys, and so forth. And the other thing is it's multi-crypto, so it will do S-MIME, it will do PGP, it will do OTR, it will do GNU-net, and you don't see anything of that. So the engine looks at what's the best available, and that's the one it's going to pick. And if it has no information on your counterpart, then it will just send it unencrypted. Because the idea of PEP is it never stops the communication, and it just picks the best protection that's available with the counterpart it's sending something to. And that's the idea, to basically make it as easy for the user, for the programmer, for the administrator, to basically put it in and run with it.
But then at the same time, also, if we use a suboptimal transport, the user will then know. We don't complicate it by saying, okay, the reason this isn't working is because we were only able to send over this transport or something. That it affects the level and the color that they receive for the trust of the message.
Yeah, so we are, for example, tough. If you do S-MIME with a certificate authority, you never get yellow. And yellow means technically perfect, but as we don't trust certificate authorities, that will never get yellow.
Sorry for the presentation turning into discussion, but do you
That's
have any
great.
plans of making it work without the interaction of the developers? So basically, could we expect in the future to connect any application to PEP interface by ourselves?
The PEP engine and the adapter could be built into anything. So it could be built into an elevator that needs to connect with a technician. It could be built into a car that communicates through whatever connected drive or similar systems to the car manufacturer's headquarters and so forth. That's the design foresees that.
And there's no centralization at all.
Possibly building it into the IP stack somewhere, so it, something in OS somewhere.
I don't know that we have plans for that, but it's certainly possible. I mean,
I will not be able to answer that.
I'm not the best person to answer that either. I'm low level, but kind of a little bit above there. But no, that's.
Let me give you them.
Thank you. I won't do that anymore. Sorry, guys. I can start singing if you would. Don't sing along. We clear the room and we're done. Yay! Thank you very much for attending. Yeah, I mean that kind of thing is certainly possible. To the extent that you can pull that in, yeah, I can't see why not. Can't give you a good reason why either, but I mean, the number of libraries external libraries rely on are fairly limited, so. Okay, I actually, so you're quitting about command line, right? Stop it. Some things that so talk about some things that the engine does. I've already talked about encryption and decryption. And we do miming, encoding, and decoding sometimes, depending upon whether that's what the application needs. So it either calls something and says, look, I've got a MIME message, you've got to decode it and send me back mine. Or it sends an object that goes to the engine through the adapter that doesn't require those things. For us, it's usually easier when we don't get those because the MIME stuff is pretty difficult. And it does message processing for the adapter. It does, and it wraps key management, generation, it does verification, and it does blacklisting. What blacklisting is let's say I've got a key for somebody that I don't want to use. We internally say, okay, don't use that key, and then we just elect a different key that we have for that identity. And it does key synchronization between different devices on the same account, which I will talk very shortly about, but I have to see the one part of the engine I have never touched is PepSync. So I will talk to you about it, but I won't start telling lies. So, now a word from our sponsor.
Question.
Answer.
How do you do key management on multiple platforms?
Yes. Okay, so if you're asking how I ensure my keys are managed on multiple platforms, that's one thing. I don't know, do we do key synchronization of the trust and stuff between devices? That will come. That's not there now, though. So, future work, but at the moment, we only deal with own identities. Yeah.
How do you manage to authenticate keys which are added to existing identity? Because you say you trust the identity.
Right, you still have to, every time there's a new key for that identity, it has to be verified with the other person. So you use these trust words, which basically, it's the same thing effectively as doing fingerprint verification, we just do it with words that are deterministically dependent upon those
okay, so you don't just trust an identity.
Right, so if I suddenly get an email from somebody who looks like my mom and has a key attached, I'm not like, oh, okay, this is your new public key. No, we don't do that. Because that would be bad. I mean, I don't know if you guys remember with...
Yes, but you said you trust identities, not keys.
The trust is attached to an identity. But if we get a new key, before we attach that key to the identity, we have to verify the key.
Okay.
And then it receives the same trust as the rest. So yeah, it is attached to the identity, but it's not automatic. Yeah.
So you said on the last slide that you will do key management.
Right.
So, for example, in the far future, I may have two apps on my telephone.
Yeah.
Both implement apps.
Okay.
Or both use apps.
They could also
They are both contained in a container, at least on Iris, where they could not talk to each other. Besides, the developer has the power to fire up those apps and has control.
Okay, so basically you're saying, so those applications can't...
How do you make those keys available to both apps?
If they are talking through Pep Engine, so if one's using Pep Engine on one side and the other is using the Pep Engine on the other side...
I mean, you do not want to repeat work, right?
Yeah, no,
But you don't necessarily want to use the same key material for different apps.
I think he's asking what if you do.
Yeah, but you also do not want to put up new identities for each new app you use, right?
Yeah, there might be, I can answer the question for Windows, let's say, or Mac. You could, for example, have, say, the Outlook plugin for Windows.
So you could, for example, have the Outlook plugin for Windows and use that for the accounts you have in there, and you could, for example, install a browser plugin to do webmailing as well. That would lead to one implementation of the Pep engine on your machine, and both applications would use that with the same keys. Now, I cannot comment on iOS because we have not had that discussion and I'm not technical enough to basically answer that. But
yeah, I think maybe I'm using a Windows machine and a Linux machine. I don't use both. So
yeah,
I want to do secure communication.
Yeah, so
it's very practical.
Yeah, there will be what was mentioned, key synchronization. So the keys will be synced between all your devices. You can put your devices into a device group with a handshake, the same trust word concept, and then basically the keys will get synced in a peer-to-peer synchronization between the devices.
And that depends upon the engine, which is the lower level component. So if you're worried about having two different applications that are both using the Pep engine, so if you've got on your iOS device, if you've got, I don't know, a chat client running, and you've got on your Linux device, you're running Mail, and you want to be able to communicate, and there's a way to do that with the transports that are within the PEP engine, KeySync will still work because the engine does that. So it's that component that does that. It's not really a matter of saying, okay, my app can't talk to your app in that sense.
So there will be another talk where all the details, how the synchronization works, will be explained?
I think Volker might.
That's actually why I'm here. I just want to know what's working behind the scenes. So
Yeah, I've tried to talk about as much as I've got. So
Let me say something in terms of the special hands-on sessions. We weren't sure how many people are there who want to go into detail, since it's so multi-platform, multi-language. It's a bit difficult for us to offer workshops for every interesting question related to every interesting language or platform or device or whatever questions you have. So we tried to contact, or we tried to ask you yesterday, email us under contact@pep.foundation. So far I haven't received any emails, but I have the feeling there are a lot of questions. So we now think we might try the other way around. So once this thing is over, we will go to the wiki and collect some questions, put it on the wiki, talk to our developers when they have time, and offer you slots, and you just come to our assembly, and then either we stay there at the table if it's just a few people, or we find a small workshop room, there's several around. So this would be the suggestion. Yeah? If you have specific questions, please come to me and tell me, because then we just set up a slot for what you want to know.
Yeah,
okay?
I don't do iOS development. In
And
fact, I
also
don't
you
touch
can
any of
talk
this
to
stuff.
me after Krista is finished, because then I can just write it down and we'll do something. So this is exactly what we want to do. Okay?
I will say a little bit about KeySync, but I can only tell you a little bit about it because, again, this is not code I've touched, but I know enough about it at least to explain in the grand sense how it works. But first, because I forced you to watch the... Okay, mainly because Liz wanted this to be played. A word from our sponsor.
PEP now has a new feature, PEP Sync. With a new version of PEP, you can synchronize all your privacy on all your devices automatically. Just confirm your trust words. PEP will automatically synchronize all your privacy. PEP keeps your privacy easy.
It was mostly to wake everybody up because he's very happy. What did I do now?
No, keep on.
Yeah, I'll keep on. If you guys want to leave, run now. I won't notice. I'm not looking up. All right. Okay. How it really works, so this is just, again, this is the general overview, although I can tell you that what's done is that it mails it really good. So, just like when Alice and Bob were confirming things for each other. Let's say I've already got it running on my Linux desktop, so I've got it running under Enigmail, and I want to also run it on Android, and I don't want to generate new keys for everybody. What I do is, when I start the account, so when I set up the account on my PEP for Android, I send an email to that account. So I send an email to myself. And that's basically a notification that, hey, there's a new device that has access to this account that wants to join the group. But of course, I don't want to just say, okay, well then I'm going to send that key out, obviously. Sending that private key out because you've got access is not enough. You have to verify trust words on both devices, just as if it were a mail sent between two different people. When those are verified, then there's a handshake, you verify and say that yes, this was the device I intended it to be, they join the group, and then you have at least the private keys are synced between those two. Because again, we don't want users actually having to transport keys around. But that's the high level view. The lower level view is either in the code or come talk with us. Because again, there are people that know more about it than I do. This is just not the thing I've been working on. And sorry, there was another guy who was going to be here with me, but he was unable to attend. So, but he does know it. Anyway, more stuff, and I'm not going to go too deeply into it, but, oh, that's actually what I just said. Never mind. Yeah, so we do message processing for the adapter. Again, we've got these callbacks that are registered in the cryptotext structure so that we can do decryption and encryption. Key management, generation, verification, and blacklisting. There are, again, callbacks to the specific library we're using, or we have language specific, and it's language specific. So, for example, if somebody speaks Turkish, we don't want to have them have to, use English trust words. That doesn't make any sense. What do we default to if they're two different languages? We default to English if they're two different languages, which is, it's hard to find a solution to that. And blacklisting, we have this database of keys that we've blacklisted that we say we don't want to use, but it's not the same as revocation or saying we never want to use it. It may just be that, for example, for the next 10 mails, I'm not going to use this key for this guy, but then later on I might want to say, okay, I can use that key again. So that's just in a database. We do mine encoding and decoding, as I said. We do that through the joys of LibEdPad. If you ever really want to have fun and have to really understand the MIME standards, sit down and look through that code, because if you don't look at the RFCs, forget it. And key synchronization between devices on the same account is just shown with big hand waviness, and my apologies for that. The About Us slides were put in very, very late, so these are really just our standardized slides, but we are primarily privacy advocates, and we developed PEP engine for the purpose to drive several crypto standards. We really want everybody using and doing things in the most secure and private way, and our goal is to, by doing this as free software, encourage people to both adopt best practices. We like to work with people, and if you've got something you want to implement on top of what we do, if you want to work with us, please contact us. We really, I mean, this project comes from this community, and we believe in what we're doing from a really high level. It's not about the money for the most part for most of us. It's really about what we do, and most of what we decide is sort of shifted in favor of privacy over other things. We have is the Android out of beta yet? Okay, so the Android port is in beta. The Outlook is not. It's out there, ready for use. iOS is on the way. And Enigmail, so we actually, our code is already in the Enigmail platform, and that's coming along pretty well. And so that's pretty well. We've got a really good partnership with the guys over at Enigmail, and I think things are moving pretty well. So if there is something that you would like to do with PEP, or you want to know more about how to do things with PEP, please, I have nothing. Mark is staring at this like that's an old picture. I just took it from the slides, not my fault. Please contact us. And this is a little shot of the Outlook platform. And I guess if you have any questions, you can ask more. I'm around. If you're tired and want to take a nap, that's also good.
I have a suggestion. If you have different languages,
yeah,
then you should first search for a common language between two persons, because maybe somebody speaks Arabian and Chinese,
yeah,
and the Chinese guy speaks Chinese and Japanese, and none of them speaks any English. So English is
having some sort of tiered thing where you know more languages would be good. I don't know if that's a future plan thing, but it's certainly. Yeah. Okay.
Mm-hmm. So you should set your preferred language and your second, third language and things like that.
No, I totally agree.
You have, just like when you do a handshake with HTTPS, you have to figure out which protocols
both people
speak and choose the one. Maybe they are both analphabets, and then you have a smiley face.
Yep.
You can say laugh, apple, tree.
Love, happy, other emoji. Yeah. Something like that. Yeah.
Good or good PEP for the people that are not using PEP but are using PGP or GP?
Yeah, so I can send an email to Leon. So I at the moment actually still use Enigmail normally, because it's good to know what I can operate with, because we don't want everything. We want you to be able to get email from anybody you can, right? So, it's important, because if somebody else is just using PGP, I don't want to make it so that they can't communicate with me. That would defeat the purpose. I would never use it.
Well, you want to do a plain text, but it's more preferred, right, to do it in a safer way.
Yeah, I mean, exactly. So I mean, no, I don't. So you're not going to decide, okay, so this guy's using Enigmail, so we're only going to communicate in plain text. Absolutely not. So no. We want to work with existing PGP implementations and other implementations, other mail transports and standards. We try to make sure that those communications are as secure as possible, whether or not they're using PEP. If that makes sense. If it doesn't, I'm really babbling today. And I'm sorry for the nervousness. I'm just not a really.
If there's questions left, Nana.
Again, if you have specific questions or want to have a workshop on something that you already know of, please stay here, come to me, and we'll set something up.
And also tonight,
Right, is it at 6 o'clock tonight?
It's at 6:45.
6:45
This
here?
room again.
yeah, 6:45 in this room. At the end of the refix the net session, which starts at 2 o'clock as well, which is quite interesting. We'll be having somewhat of a panel discussing the general, like, how do we go on with GPG and Manila. They have another project being there for Ulster, which also goes like the same direction. Okay, let's just make it like ultimately intuitive. And I think that would be very interesting, especially for the ones who now attended like both talks, to actually like get the